In this module, we're going to see how to price caplets and floorlets. In particular, we will focus on caplets, but floorlets are priced in the same way. Caplets and floorlets, and more generally caps and floors, are very liquidly traded fixed income derivative securities that are found in the marketplace. So it's important that we understand how to price these securities and understand the mechanics behind these securities. A caplet is similar to a European call option on the short rate RT. It is usually settled in arrears, but a caplet may also be settled in advance. If the maturity is time tau and the strike is C, then the payoff of a caplet is R tau minus 1 minus C, the positive part. Or if you like, this is the maximum of 0 and R tau minus 1 minus C. This payment occurs at time tau. So this is what we mean by being settled in arrears. So you can think of the caplet as being a call option on the short rate prevailing at time tau minus 1 but settled at time tau. A floorlet is the same as a caplet except the payoff is C minus R tau minus 1 positive part, or as we've been writing, the maximum of 0 and C minus R tau minus 1. But again, this payoff would typically take place at time tau. A cap consists of a sequence of caplets, all of which have the same strike. So these caplets will all have different maturities, but all have the same strike. And a floor consists of a sequence of floorlets, again, all of them having the same strike, but different maturities. So here's our familiar short rate lattice. This is the lattice we've been working with throughout this section on fixed income derivative securities. We start off with 6% for the short rate, and it grows by a factor of U equals 1.25, or falls by a factor of D equals 0.9 in each period. What we're going to do is we're going to price a caplet with this model. So we're going to assume the expiration of the caplet is T equals 6. In other words, the payment actually takes place at T equals 6. We'll assume a strike of 2% for the caplet, and now we're going to go ahead and price it. But there's one thing to keep in mind here. The payoff of the caplet takes place in arrears. So for example, suppose we're at this node down here, 0.028. Now in reality, the payment that is determined at that node will take place at time T equals 6. But it is somewhat awkward to record the payment here or here, because if we were to record the payment at this point, well, we're not sure actually which node is responsible for this payment. Is it this node, 0.028, or is it this node, 0.045? So that makes the accounting just a little bit awkward. So instead what we'll do is we will actually record the cash flow, the final cash flow, at the node at which it is determined. So that is at T equals 5, but we will discount it appropriately to reflect the fact that the payment does not take place until T equals 6. And that is what we've done here. So if we look at this point, 0.015, well, 0.015 is equal to the payoff of the caplet determined at T equals 5. So this is the maximum of 0, and the short rate that prevails at that period, which is 3.54%, minus the strike 0.02. So this is the payoff of the caplet, which is determined at this node. However, it is not paid until time T equals 6, and so that is why we must discount it by 1 plus 3.54% to reflect the fact that the payment is made in arrears. So we do that for all of the nodes at time T equals 5. These are all the payments of the caplet discounted by one period. Once we do that, we can work backwards in the lattice using our usual risk-neutral pricing. And just to remind ourselves, our usual risk-neutral pricing takes the following form. ST is the price of whatever security we want to price, and it's equal to the expected value at conditional and time T information using the risk-neutral probabilities of ST plus 1 divided by 1 plus RT, where RT, of course, is the short rate prevailing at the node you are at time T. So this is risk-neutral pricing for a security that does not pay any intermediate cash flows or coupons. If the security did pay a coupon at time T plus 1 or some intermediate cash flow at time T plus 1, we would of course inject that cash flow into this point here. And here we can see the lattice with all of the caplet prices displayed. For example, the value of 0.021 is calculated as follows. It is simply 1 over 1 plus 3.94%. Remember, that is the short rate prevailing at this node here, 3.94%. So we get simply 1 over 1 plus 3.94% times the expected value of the caplet 1 period ahead using the risk neutral probabilities, which are a half and a half. 1 period ahead, it's either worth 0.028, which we have here, or 0.015, which is what we have down here. So we get the value of the caplet at this node. So again, all we're doing is using what we had on the previous slide. We're using the fact that ST equals the expected value of ST plus 1 over 1 plus RT. So we start off at time t equals 5. At time t equals 5, that is where t plus 1 equals 5. We know the value of the caplet. It's this value, these values here. And we just work backwards 1 period at a time to get to time 0. And we see a caplet value of 0.042. Now, just to be clear, this is the value of the security that pays off R5 minus 2%, the maximum of this, and it's paid at time t equal to 6. Well, this 0.042 is how much this is worth, but in practice, of course, you mightn't actually buy just one of these. You might buy 1 million of these. So $1 million, that would be a notional of $1 million. The price of that would therefore be 0.042 times $1 million. So this value here is the value for a notional of $1. We're multiplying this payoff by, if you like, $1 here. In general, in practice, you would actually be buying many of these or selling many of these, and so you would need to multiply the price you obtain here by the notional of the caplet. And here we see our familiar spreadsheet that I hope you've opened in front of you while you go through these calculations. Here we have our parameters for our short rate lattice, or starting off at 6%, risk neutral probabilities of a half and a half, U equals 1.25, D equals 9. So here we have our familiar short rate lattice that we're using throughout these examples. Down here we see how to price the caplet. The 0.0149 is the payoff of the caplet at time as determined at time t equals 5. So that is the maximum of 0, and the short rate, which is G16, which is 3.5%, minus the strike 2%. But of course that payment does not take place until time t equals 6, so we have to discount by the 1 plus the short rate prevailing at that node, which is again in G16. So we compute the value of the caplet at time t equals 5, and then we just use risk neutral pricing to work backwards. And I've highlighted the cell here in bold because it is this cell which contains the formula, the risk neutral pricing formula for the value of the caplet at this cell. We can then copy and drag this cell formula throughout the lattice to determine the prices at every node. And again, we see the value of the caplet is 0.0420.